Hey everybody, this is Gregory from Dapp University. So I'm so excited to be on freeCodeCamp today to teach you how to become a blockchain developer. I'm going to take you over the shoulder and teach you how to write Ethereum smart contracts with a Solidity programming language for the blockchain. And you don't even have to know anything about Solidity or blockchain to follow along. So I've compiled this multi-part tutorial series into one massive video for freeCodeCamp, and you can follow along with the code examples step by step on my website. There's an article that I'm going to put a link to down in the description below. And finally, if you're serious about becoming a blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. And I'll also put a link to that down in the description below. Solidity is the main programming language for writing smart contracts on the Ethereum blockchain. It's a contract-oriented language, which basically means that smart contracts are the main way that you organize code and store data and write all of your programming logic. And it's a high-level language for implementing these smart contracts. It looks a lot like JavaScript and Python and C++, as you see right here. And it's used to run on the Ethereum virtual machine, which is basically, the thing that runs the code on the Ethereum blockchain. So Solidity is statically typed as opposed to a dynamically typed language, and it supports stuff like inheritance, libraries, and lots of other stuff. So enough of talking about Solidity, let's actually jump in and start writing some Solidity code. This is a website that allows you to write Solidity smart contracts in your browser. And it has a text editor here and allows you to compile them and deploy them and run them. And that's exactly what I'm going to use for this tutorial. You won't have to download anything on your computer. You won't have to install anything. You can just visit this website to use Remix, and we'll write the smart contracts that way. So in order to do that, I'm going to go over here to this browser folder. You can see the file browser over here. This is some basic smart contracts that come preloaded inside of this IDE. I'm just going to create a new one here. I think I can just create a new file. This will be a Solidity file. We'll call it my contract, and we're going to write a smart contract inside of here. I'll do this by first declaring the version of Solidity that we want to use. We just do that like this. We say pragma Solidity, and I'm going to use a caret to specify a version greater than the one we want to use. And I'm going to say version 0.4.24. And I'm going to end each line like this with a semicolon. And next, I'm actually going to declare the smart contract. So before I do that, I'll explain a little bit more about what a smart contract is. Smart contract is code that gets executed on the blockchain. In this case, this is going to be the Ethereum blockchain, since we're using Solidity for this Ethereum smart contract. And this smart contract is kind of like a microservice out on the web. It's going to be accessible to everyone on the blockchain. They'll be able to see this smart contract. They'll be able to use it. They'll be able to read and write data with it and actually execute any code that we write inside of here. So it's going to be public. And that's kind of why I call it like a microservice. It's more than just a class, like in an object-oriented system or something like that. It's actually something that's publicly accessible. So it's going to look something like a class, though, because that's how we're going to actually, keep all the code inside of here. So I'll show you how to do that. We'll start by saying contract. We'll say my contract. And I'm going to open this with some curly braces, and it'll notice that the editor closes this automatically for us, which is really nice. And what I'm going to do first is just show you how to read and write a value from a variable inside of here. Now, like I said earlier, Solidity is a statically typed language, so we're going to actually have to declare the type, the data type of the variable we want to store. So in this case, we're just going to store a string, and we'll declare a string, and we'll say value. Now let me explain something about this value. This value is going to represent, a variable that belongs to this entire smart contract. So this isn't like a local variable. It's actually a variable that this entire contract will know about. And what that means with a smart contract is that data is actually going to get stored on the blockchain in storage. So if we set this value, we're actually going to be writing data to the blockchain. That's different from a local variable that I might just set inside of a function that would be local to that function scope and would disappear instantly once that function is called. Instead, this value is actually going to be stored on the blockchain. So let's create a way to just read this value. So I can do this by writing a function in Solidity like this. We just start with the function keyword. And I say, I'm just going to call the function get. It's going to get this value. And we'll just open the braces for now. I'm going to write some more code here in a second. We can see some warnings coming up, but I'll fill this out more. We'll say just return value. Okay? And that's a really basic way to do this. I'm going to add some more to this. I'm going to say this is also public. All right? Which basically is setting the visibility of this function. That's what that's called in Solidity, is setting the visibility. So that knows that this function can be called by anyone who has access to the smart contract on the blockchain, not just inside this contract. So I'm also going to set a return value, say returns string. All right, that makes our warning disappear down here. And that just tells our function that we're always going to return a string data type. And we know that's the same data type as value because we declared it here. Now I'm also going to look at this warning down here which says this function state mutability can be restricted. So basically what this is saying is in Solidity now, in this newest version, since we're not actually changing this value, we're not changing anything inside this function, we want to add an additional modifier here which just says view. All right, and that makes that warning go away. So now I'm going to set a new function or write a new function that's called set. Say function. It's going to allow us to set this value. I'll say set and say string. I'll say value. All right. And I'm also going to, set the visibility of this function. We're going to call it public, which means that anyone will be able to set this value on the blockchain. And I'll say value equals this value that we're passing in. All right. Let me explain that. I'm using value as an underscore here because I want to differentiate between this value that's getting passed in and the value that's referenced here. Now inside of here, this value without an underscore is referencing this, state variable that we set up earlier that's actually getting stored to the blockchain. And this value, Solidity knows that it's just a local variable because I passed it in and I, prepended it with an underscore like this. And also notice that I declared the data type of the function argument. We need that inside Solidity because it needs to know the type of the data that's getting passed in. All right, and now we have a way to actually read this value and set it. The next thing I'm going to show you is how to set this value whenever we deploy the smart contract or whenever it's generated for the first time. And I'm going to do this with a constructor function. So if you're familiar with other programming languages where you might write, classes or something like that, you might be familiar with a constructor function, which is basically a function that's called whenever this contract is instantiated, or in this case, it's going to be whenever the contract is created or whenever the smart contract is deployed to the blockchain. And in the newer versions of Solidity, we do that like this. We say constructor, and we just, say it's public. And we can, write code inside of this constructor that gets called whenever this contract is created. And we'll say, value. We'll just set it as, my value. All right. There we go. So that's a complete smart contract that, sets this value whenever it's deployed. So it will have some sort of default value. And then we'll have, some functions that allow us to read that value from the blockchain. And then we'll have a function that allows us to create that value as well. So now I can go to this tab over here in Remix and I can compile it. We can select the compiler version. And I'm going to say, let's see here, 0.4.25. We'll start to compile it and see what happens. All right. And now what I'm going to do is actually run the smart contract. You'll see some options over here. I'm just going to say JavaScript virtual machine, which basically what that's going to do is give us a test blockchain in the browser. So we don't have to connect to a blockchain of any kind. We can just, compile this and run it and deploy it inside of our browser, which is pretty cool. And it's going to give us some, free Ethereum accounts over here. Now, don't worry if you don't quite understand what all these values mean just yet. That's okay. I can explain those more. But for now, we're going to just keep my contract and we're going to deploy it. All right, there we go. It's deployed. So now what I can do is click on this little down arrow here, and we can see the functions that are available to us in the smart contract. We can see the set function and the get function. These are the functions that we created over here. The set function is going to allow us to update it, and the get functions allow us to get it. So I'll click get, and we should probably see the value that we created inside the constructor. We set it here. So let's get it. All right, there we go. It's my value. And we can see some activity in this log down here. We can see that there's a call to myContract.get. And now let's set it. So I'm going to enter the quotations for the string, and I'm going to say new value. All right, let's click set. All right, and we can see that worked. So you can see the transaction history over here. Let's look at the value. All right, it's new value. There we go. That's a complete smart contract that allows you to get and set a value on the blockchain. Now let me explain what's going on here. This is a list of transactions that are occurring on the Ethereum blockchain. So the Ethereum blockchain is made up of bundles of records that are chained together into blocks that make up the blockchain. And the basic unit of all those blocks are these transactions. So we can see transaction receipts. We can actually click the down arrows here. We can see all the details of those transaction receipts. And I've got other videos on this channel that kind of talk about that in detail. If you want to know more about that, just feel free to look for those. All right, that's it, guys. That's how you can write your first smart contract in the Solidity programming language. Again, that's supposed to be just a high-level overview of Solidity and how to get started writing your first smart contracts and using the programming language itself and using the Remix IDE in your browser to get started easily without having to download any tools or anything like that. The first thing I want to do in this video is actually update the smart contract code that we wrote in the last video to support the newest version of the Solidity programming language, which is 0.5.1, I believe. You can actually see the compiler version over here has changed. And in the last video, we wrote this smart contract, and there's actually some compilation errors you can see over here on the right. So you have to update this code to support the newest version of the Solidity programming language. And I wanted to go ahead and do this. I wanted to go ahead and support the new version of Solidity so that when I make more videos in this series, they'll be up to date and you'll have the newest version. So let's see what we need to do. We can read the error. It says basically the data location must be memory. And that's actually the error in both cases. So all we need to do in this case is actually just return memory here. And then whenever we're passing in the value string, we actually need to put memory here as well. All right. Actually, that needs to be before value, my fault. And now the errors go away. So we will select the newest compiler version. We'll say, let's do the latest complete version, 0.5.1. Start to compile. And hopefully the compilation will work. Yep, it worked. So let's go to run, and we'll deploy. And let's see if it worked. So get the value. Yep, it worked. Awesome. Now let's move on to the next part of this tutorial where we'll actually cover the content for this video, which is going to be, the basic data types and data structures in Solidity and how you can use them when you're developing your own smart contracts. So I will change some values in here to kind of show you what that is. The first thing I want to talk about are, the different ways we can work with these state variables, right? So the first thing I want to mention is, we had this string value here that we had declared, and we set it here inside this set function, and we had this getter function where we read that value, right? So Solidity has a shortcut where I don't even need this function. I can actually just read this string value for free. I can actually get this function for free. I can take this out and just declare this public. And that's declaring the visibility of the state variable here. Actually, public goes before. So I'll save that and I'll compile it. And I'll run it. And we'll see that a get getter function called value, the same name as the state variable, was exposed to us by the smart contract. And we can see it works just the same way as that other function did. So that's a really nice way to save yourself from writing extra code. You can just get that function for free exposed to the public interface of the smart contract whenever you store your state variables that way. Okay, so the next thing I want to talk about inside of here is actually, we could set this as a default value. We don't necessarily have to put, my value here in the constructor. We could just say this, all right? I could take this away. Oops. Take this away. And we will run that again. Let's just clear this out. Deploy. All right. And we can, actually, sorry, we need to compile it first. Deploy it again. Get the value, and we can see it's my value. We can also set this value as a constant if we don't want it to change. If we don't want to allow a user to set this value, we want it to stay the same, we can just say constant. All right, that actually declares a constant. We have to remove this function. We can't update this value at all. Solidity won't let us do that. So we could just do that. I'll deploy this again, and we can still see our values here as my value. So yeah, that's how you would add a constant to your state variables, or make your state variables a constant. Now let's look at some other data types in Solidity. Let's just change this name. We'll call this like string value. All right, let's just deploy that. We can see this instance here again. String value, all right, it's my value. Now let's explore some other data types. We can say a Boolean type. We'll say bool, public is equal to, I'm going to remove this constant for now. My bool equals true, all right? So this just accepts true or false. We can deploy that. See this, my bool, right? It's true. String value is my value. Say, or my string, just save that, just for fun. And we can also see that, we support data types like integers. So integers can be signed or unsigned. So what does that mean? Well, we can do a default int, which would be public my int equals 1, right? So we can deploy this and see. Let's actually just clear this out. Sorry, deploy this and see my int is equal to 1. So the difference between an int and a uint, or an unsigned integer, is that an integer can be signed in a, an integer can be signed and a uint can be unsigned. So what does that mean? Well, basically an int can be negative. So I can do -1, all right? And deploy that. That's a signed integer. It has a sign in front of it. It can be positive or negative, and a uint can't. So we'll deploy that, clear these out, and see my uint, all right, and my int, all right. Yeah, so -1 can work for an int, and they can't do negatives on unsigned integers. You can also specify the amount of bytes or bits in an integer. So we can say uint 8. Public equals my uint 8, sorry, equals like, all right, oops, let's do a small number. And we can see my uint 8, all right. And so if we do uint here, it defaults to 256, I believe. Uint 256, public, my uint, okay. So that gives you a basic overview of all those basic data types. I don't want to bore you with all the pedantic details of this kind of stuff, but this is helpful to know, I feel like. The next thing I want to show you is an enum. So what is an enum and how do you use it? Well, an enum is basically an enumerated list that's going to allow us to keep track of a set list of things in our contract. So I'll show you what that means. So basically, I can declare an enum like this. I'll say enum state. And I'll give it some options here. I'll say waiting, ready, active, all right? And this is going to allow us to keep a list of these 3 states inside the smart contract. We'll be able to reference this to see what the current state is. And it'll give us some options whenever we're updating the state and like checking against this. So I'll show you an example. We'll actually store this like this. We'll declare state, public, state, like this, right? So basically, this is going to give us a public, we're going to be able to access this publicly with that getter. So inside of here, I'll do a constructor. I'll say constructor, I'll say public, I'll say state equals state active. All right, so I'll go ahead and set the default state to active, right? So actually, let's do this. Let's do waiting. And then I'll create a function to activate it. And I'll say activate. And I'll say public state equals state dot active. So we can actually choose, we can choose this value out of this enum list and update the state to that value. All right. So whenever we call this function, it'll change the state to the active state. And let's get a function that checks to see if the state is active. We'll say function is active. And we'll say public view returns bool. All right, we'll say return state equal to state.active. So that's what we'll do inside here. We'll just check to see if the state currently is active. All right, so let's see if we have any errors. Looks good. I will compile this. All right, we'll go run, deploy. And all right, let's check the state. So is the state active? All right, no, it's false. So that's true. It's not active. It's in waiting. So let's actually check the state. So state is 0. So 0 corresponds to the first item in this list, 0, which is waiting. And I'll click activate. All right. So actually call the activate function, which updates the state to active. Let's see if it's active. Yep, it's true. And let's check the state. So now the state is 2, which is 0, 1, 2. All right, so that's an idea of how you use enums. Let's look at the next concept that I want to show you. The next concept I want to show you is let's do structs. So structs are basically a way for you to define your own data structures inside Solidity. We'll do that like this. We'll say we'll create a struct right here. We'll call it person. So struct person, and we'll give it some characteristics. We'll say string first name and string last name. Okay. So basically what's going on here is this allows us to basically model, our own sort of arbitrary data. I'm just going to model a person with this struct that's going to have a few attributes. It's going to have a first name attribute that's going to be a string and a last name attribute that's also going to be a string. And we can put these structs inside of like arrays and mappings and things like that. I'll show you that here in a minute inside this video. But for now, just know that we declare that we've defined this new data type person inside the smart contract with a struct that's going to have a first name and a last name. Okay, so let's actually create a function that allows us to instantiate a new person, create a new one, and we'll actually keep track of a bunch of these person structs inside of a people array. All right. So let's do that like this. Let's say let's keep track of a bunch of different persons so we can create new ones. We'll say person. This will be an array, public people. All right. So let's see what's happening here. People is a state variable here, and it's public, so we can read it outside the smart contract. And it's an array here of these data type person, right? So we declare the data type first, which is person, which we defined here with struct. It's an array that contains these person structs. It's public, and it's stored with the people state variable. So we can add people to this array, or person structs to this array like this. So create a function, say function add person. It's a string. This is a Solidity 5 update, memory, or 0.5, sorry, first name. And then we'll say string, memory, last name. We'll say public. And we'll do this inside here. We'll say people, push. So push is a function we can call in arrays to add a new item at to the array, And we'll push a new instance of this person struct. So we can create a new instance like this. We just call person, right? And we pass in these attributes. So we say first name. Oops, sorry. Name and last name. All right. And what we can do here is, well, yeah, we've added it. Let's go ahead and do it. So let's just compile this and run it. We'll deploy this. All right. So let's see what happens. So people, let's go ahead and add the person. Add person. Oops, sorry. Let's do the first name. So first name will be DAP. Last name will be university. We'll add person. Okay. Awesome. So that didn't give us any errors. Now, how do we read this person out of here? That's a good question. So we added this person to an array, but this function, whenever we call this person, this people function, it's not going to return the entire array of people. That's because this is, we don't know the size of this array is in Solidity. And we have an array of unknown size. It's not going to return the entire array. So basically, we need to reference the person by ID. So whenever we get this function, it expects an argument, which is going to be the index of the person inside this array. So for example, we know we added one person in there. So we will add people. We'll say 0. All right, there you go. DAP university. So what happens if we reference, a person that doesn't exist? Say person, like 1 people. It's going to give us an error. It's an invalid opcode error. That's because there's no one in there at position 1. So how do we fix that problem? Let's keep track of that like this. So basically, we would keep an internal count of the people. We'd say something like this: uint 256 people count. Okay. And that's going to basically give us a counter cache that will increment every time a person's added. So we can say something like people count plus equals 1. All right. And we can do that after, I guess. All right, save that, deploy. And now we can, actually, let's make this public. Oops, sorry, it's before. Let's try it again. So now we can add the person, DAP university. Add person. And we can see people count is 1. So we would do 1 minus that, people. All right, DAP university. We do 1 minus that because it's a 0-based index, which means the first item, is at index 0, and the second one's at index 1, et cetera, et cetera. The next thing I want to show you is how to do a similar concept here, but model it a little differently. So instead of using an array, we're actually going to use a mapping. So what is a mapping? A mapping is basically like an associative array. So instead of having, just an array, and we know that each index of the item in the array, we can actually associate it to a value. So that's like a hash table or a hash map or a hash, and other programming languages that you might be familiar with, where basically you can reference things by, a key value. It's key value pair. So instead of having people like this, instead of it being an array, I'm going to change it down here. I'm going to say this is going to be mapping. Mapping uint person. Okay. So uint is going to be the key, and the person is going to be a value. So this mapping is, like I said, an associative array that's going to take a key value pair. The key is going to be an unsigned integer. We'll treat this like an ID. So it'd be kind of like our database lookup, where we have an ID and then a record. So this is going to return kind of like a record, like a person record, or a person struct in this case. And it'll be public, and it'll be people. And it is kind of a fair comparison to compare this to a database, because, blockchain kind of is a big database, and these structs are, getting stored in storage on the blockchain with this mapping. All right, so person, string, first name, last name, and we'll do add person. So we'll need to modify this function. We'll still take the first name, we'll still take the last name, but we're going to put this in the mapping instead of the array. So I'm going to move this people count back up here. We're going to want to keep track of this just like we did earlier so we know how many people are in this mapping. But we'll add it to the mapping like this. We'll say people, people count. This will be our ID. So if it starts at 0, which it will, do this. All right, people count plus equals 1. That'll be the new ID of the person that's going to go in here. So this will be person number 1 the first time we add this. We'll say this is going to be a new person. And be we'll give this an ID. We'll say uint ID. Okay. People count. And then we'll say first name. And then last name. All right, and we'll take this out. All right, let's see if that worked. Clear this out. Deploy the contract. So we'll do first name is DAP University. Add person. Okay, so let's see, people count is 1 now, and we'll go to people. This time it won't be based on the array index, it'll actually be on the ID, so we can actually reference person 1. All right, we'll do people 1. There we go, DAP University. So let me explain a couple more things about structs while we're here. We need to keep track of this people count because there's no way to know the size of this mapping in Solidity. Basically, any key that doesn't have a value set for it's going to turn a default value, which is going to be like an empty struct here. So if I do like, person, 10 or like 9999 people, it's just going to return default values. So what are the default values for the struct person? ID for uint is going to be 0. And then these blank strings for first name and last name. So that's why we need to have a person count. So if you were going to use this like as a data storage, and you wanted to like show all the people or all the persons in your people mapping in your app or something like that, reading from the smart contract, you want to know how many are actually in there, and you want to do that with a counter cache. So that way, if you wanted to basically like the same thing with those variable size arrays. Like if you wanted to get all the items, you need to first make a call to find out how many there are. That's what you use the counter cache for. And then you basically create a loop to read out each one by one. So yeah, it can be kind of a pain, but that's sort of just the state of things and what you have to do. I'm going to go ahead and pick up where we left off in the last video. I'm going to use this, my contract that we built where we added a person struct to this mapping of people. So if you haven't seen that last video, go ahead and check that out. It's not necessary, but you can probably follow along with this video if you want to. What I'm going to do now is show you a little more about these modifiers like public and things like that. I think we talked about that in the first video, but I'm going to go just a little further. So what I can do is, show you another modifier, which is basically like internal. So that's different from public. Public is a function that can be called, on the public interface of the smart contract. You can see, the public functions listed here on the side. So I'll go ahead and create a private function, or an internal function, excuse me. I'll say function. We're just going to take this people count and wrap it in its own function to show you how that works. We'll say increment count. We'll just make this a function, and we can call it internal. That's a different modifier. We'll just take this people count, and we'll paste it inside of here. All right, and we'll just say increment count. Call that function, and we'll run it. See the smart contract, we'll add the person. We'll say DAP University. And I'll click add person. And there we go. It incremented the count. You can see the people count has been changed. You can say Joe Blow. And the count's changed. So that's a way that you can, use other functions that are going to be internal. And we can see this increment count function isn't added to this list over here. It's not exposed to, things outside of the smart contract. External callers can't use it. So that's an example of, other, types of visibility of functions in Solidity. Let's talk about function modifiers. So we can add, more, words and terms to the end of this function to change how it behaves. And I'll show you an example. So we're going to create our own custom modifier actually inside of this smart contract so that only certain people can call this add person function. All right. So what I'm going to do is basically, make this smart contract have an owner or like an admin. And we're going to say that only the owner can call this add person function, and any other account connected to the network, whenever they try to, add a person, they won't be able to. And that'll show you how we can add an extra modifier to this function to make that happen. Basically, we'll just add a modifier that says that only the owner of this smart contract can do that. So first, we need to, well, actually, that'll just look like this. We'll say only owner. That's what the modifier will look like. Now, this only owner modifier doesn't exist yet, so let's go ahead and create it. All right, so we'll do that like this. First, we need to keep track of an owner. We'll say the owner is, address. I'm not sure if we talked about this in the data types video, but, an address is a data type inside of Solidity. Like an address that's on the network, an account. So this will be the address. We're just going to declare it here. We're not going to set it just yet. We can set it like this. We can do it inside the constructor. Well, actually, let's not do that just yet. So that will be the owner. We basically just create a modifier like this. We say modifier. Say only owner. It's like a function. And what we'll do inside of here is write the logic that makes sure that, whoever's, calling this smart contract is the owner. So that's what we're defining here. Only owner and only owner. So how do we do that? How do we say the person who's calling this function is the owner of this smart contract? Well, we're going to compare it to this owner right here. But how do we know who's calling the function? Well, Solidity has a global keyword called MSG, which basically stands for the function metadata that's passed in. And we're not actually going to pass in any metadata here. It's going to be implied. So basically, we have access to MSG.sender. And this is basically a special thing inside of Solidity that tells us the account, his address, who called the function. And basically, we can just say, is this person the owner? We can just, compare equality of the person who's calling the function with this owner that we're going to store here in a second. All right. And if they're not, we actually want to throw an error. All right. So this is going to show you another concept in Solidity about error handling. So we can throw an error in Solidity, like, I think earlier we had some errors happen, like here's an error. We actually want to trigger an error if this person, is not the owner. We want to revert the transaction. And we can do that like this. We say require, MSG.sender is equal to the owner. So basically anything inside of this require, if it evaluates to true, then this passes. If it evaluates to false, then this will throw an error. We basically are saying require that whatever you put inside of here is true. All right. And then after this, we can basically just do this. All right. And now our only owner modifier is complete. So basically now we have this modifier that's defined here, and we add it here. And basically we say if the person who is calling this function is the owner, then we can actually run this function, and if they're not, we're going to create a failure. We're going to revert the transaction, and also whoever's doing this, whatever, like this code won't run, so they won't pay this gas fee. All right, so now we need to set the owner, and I'm just going to do that inside of constructor. We'll use msg.sender as well. Say function constructor, and we'll just open this curly braces, and we'll say owner equals to msg.sender. Sorry, we don't need the function keyword here. And we also need to make this public. All right. So I'll save that. So whenever you deploy the smart contract, like this constructor gets run, and the msg.sender is actually the account that deploys the smart contract, and they're going to get set to this owner state variable, right? This address owner. And basically, that same address is the only person that's going to be able to call this add person function. All right. And if they, this code will run and we'll be able to add a person. And if we switch accounts to some other account over here, then it won't work. So let's just try that. All right, deploy this. We will, deploy with this account. So let's change to that account. We'll add the person. Actually, I don't know if it deployed that account or not. Let's try it again. So make sure on the first account, we'll deploy. All right. We'll add a person. We'll say DAP University. We'll add the person. All right, let's see here. All right, it worked. The people count is 1. Now we'll say, Joe Blow, and we'll change accounts to this one. And we'll try to call it again. We'll add a person. And we see it has failed. And the people count has not changed at all. So it worked. So we've kept track of the owner, and we say only the owner can do it. Now while we're here, I'm going to show you a little code formatting that I like to do sometimes. This is getting kind of long, and sometimes, if you're like me and you have a text editor with a whole bunch of panes open, I like to keep my columns kind of short sometimes, especially with Solidity. And it kind of makes it easier to maintain these functions when the arguments start getting long and you're using get and things like that. Sometimes I will just break these up like this. All right, and then I'll actually put the modifiers. If you have a bunch of modifiers, sometimes this makes it easier to read. And also when I'm writing my own Solidity source code, I only use 2 spaces. I don't use 4. But yeah, that's sometimes how I break these functions up. So I can see the function name and then the arguments. Then I can see the modifiers, and then I can actually see the code that gets executed inside of here. And it can make your smart contract kind of long, but it can be, sometimes this will catch you. If you have too many, if you have 3 visibility and modifiers on here, sometimes it can be kind of tricky. So I like doing this. All right, so next, I'm going to show you how to work with time in Solidity, okay? So what we can do is basically compare time in Solidity. And instead of this saying only owner can do this, let's say that you can only call this function if a certain time has passed. So let's pretend like, this is a contract that is only open at a certain time. So we'll say, instead of only owner, we'll say only while open. Only while open. All right. And this opening state is going to be determined by a time. So once we've passed a certain time in history in the future, then we'll let you call this function. If it's before that, we won't do it. So that's really useful if you're building a crowd sale or something like that has an opening time, like an ICO smart contract, and you say, hey, we can only let you contribute Ether after the first of the month. Well, you just figure out what time that is and say, hey, if you make a contribution before then, we'll throw an error. So I'll say only while open, all right? And instead of requiring that MSG, that sender is the owner, right? We're actually going to just take this out. We're going to say, we're going to make sure that the current time is in the future, beyond a certain opening time. So let's do uint 256 opening time. All right. So how do we do this? Well, we need to set this opening time somehow. All right. So the opening time is actually expressed in seconds, inside Solidity, or these timestamps are expressed in seconds inside Solidity. And seconds of what? Well, it's epoch time, which if you're not familiar with that, it's a concept in computer science that's like the epoch is a specific time. I can't remember the actual date. It's like a date in the 60s or 70s or something like that. And basically, we just add seconds since that point in time in history. So this is the current epoch timestamp is this many seconds since the epoch time. And I guess there's probably a link here where you can read more about that. Yeah, the Unix epoch clock. I'm sure you can get on Wikipedia and figure all that out, but basically, this is the current epoch time and it's changing. So we use these seconds values. So this is like the current, epoch timestamp. We'll say this. All right. So this is how we could set this. And it's, uint 256 is going to store this big number of seconds since that timestamp. And that's going to be our opening time. And so how do we compare that to now? So how do you get now in Solidity? Well, there's no perfect way to do it, but the best way is to get the current block's timestamp. All right. So how do we do that? Well, just like MSG, there's a global variable in Solidity called block dot, and we can say block dot timestamp. All right, and we can say, is the block dot timestamp, is it greater than or equal to the opening time? All right. So basically, if it's after the opening time, we're going to let you call this function. And if it's not, then we won't. All right, so let's give this a try. I'm going to update this timestamp. Let's refresh it. Let's see. This is the current one. I'll paste this in here. So 15, I'm going to add 60 seconds, so a minute. So I'm going to deploy this, and it will be, it shouldn't work right now, so we can try to call add person. We'll try to add DApp University. Okay, we'll add person, and we'll see that it reverted. Okay, and now we can check the timestamp. We're not there yet, so I'll just pause the video and wait for this to pass 75. I think that's the actual time. Yeah, 75. All right, I'll pause the video. Pause the video, giving us plenty of time. We're past the timestamp. You can see it's 793, and we're at 775. So let's deploy it again. Or actually, let's not deploy it again. Let's just do Joe Blow, add person, and it worked. So that's how you can use time in Solidity. You can get the current time and set a time value with seconds. And so that's what I'm going to call today, guys. I hope you all like this video. Let me know how you're enjoying these Solidity videos. Let me know if I've missed anything, or if there's something you want to learn, or if you're just not liking them, that's okay too. Just let me know down in the comment section below. Let's use the same My Contract example that we've been using throughout this tutorial series. And you don't necessarily have to have been following along with every video in this series. You can kind of just pick back up with this one probably. So yeah, let's go ahead and jump in and start programming. What I'm going to show you first is how to write a function that accepts Ether. So basically, like, how can we send Ether in when we call a function and do stuff with it? So I'll show you how to do that. First, we'll create a function called BuyToken. Say BuyToken. And this function is going to kind of emulate what happens in an ICO, like a crowd sale or a pre-sale or something like that on Ethereum, where you're buying ERC20 tokens. I'm not going to like code out an entire ERC20 token smart contract right here, or code out a crowd sale smart contract. I've got several other tutorials that show you how to code your own cryptocurrency on Ethereum with build an ERC20 token step by step and a real world crowd sale, things like that. So you can check out those other videos if you're interested. But what we're going to do is basically create this function called BuyToken that's going to simulate what happens. It's not going to do everything, but it'll at least give you an idea of how that works. So we'll call this BuyToken. And inside here, what we basically want to do is buy a token, and we also want to send Ether to the wallet. So what's going to happen is someone's going to call this function, and they're going to send Ether when they call this function. And when they do, we're going to issue them a token, and then the wallet is actually going to receive the Ether that they sent in when they call this function. So I'll show you how to do that. First, I'm going to create a way to track the tokens. And basically all this is going to do is track this person's balance. So we'll use a mapping for that. We'll say mapping. And again, if you didn't check out the other videos, the mapping is like an associative array where we have key value pairs. So we'll say address will be the key, and the value will be an unsigned integer. All right, and this will be public. All right, this will give us a function for free that will allow us to read this value, and we'll just call this balances. So what we'll do, and when we buy a token, we'll basically just say balances of whoever called this function. So if you'll remember from the last videos in this series, we get that value with msg.sender. This is the account that's calling this function. And we will just increment this count by 1. Now this is not really fancy. We're basically just saying whenever you call this function, you're going to buy 1 token. We're not using a rate of redemption or anything like that. This is just to kind of show you how this works. This is not very sophisticated. But basically that'll just increment your balance, inside this token contract by 1. Whenever we do that, we want to transfer funds that are sent in with this smart contract to a wallet. All right. So how do we do that? Well, first we keep track of a wallet. We'll just declare a state variable here. We'll say address wallet. And we want to send funds to this wallet, okay? And we do that like this. And I'm actually going to show you something in a minute that's going to be a Solidity 0.5 update. So if you've been using previous version of Solidity, we have to make a change here. I'll go back to that in a minute. But anyways, let's transfer funds to this wallet. We'll do that like this. So we'll say wallet, transfer. And we want to transfer in the funds that are sent by this function. Transfer the funds that are sent in by this function to this wallet. So how do we do that? Well, how do we actually know what the value is that's getting sent in? Well, just like msg.sender, MSG has another property called value. So we can say msg.value. All right. And that's going to tell us exactly how much ether or Wei is sent in by the person who's sending this function. So I'll show you how that works. So what that's going to do is take the ether that's sent in with this function call and transfer it to this wallet right here. Now this is not complete. There's a lot of things that actually need to change in order for this to work properly. You can see these X's over here, these compiler errors. So the first thing we need to do is set a wallet. Let's do that inside a constructor. We'll do that whenever we deploy the smart contract. So we'll say constructor. We'll say address, wallet. We'll say public. And we'll say wallet is just equal to the wallet we pass in. All right, so we're still getting errors. Now let's see what they are. The first thing we need to do in order to make this function accept ether, well, actually first we need to make it public so that people can call it. We say public. All right. So now people will actually be able to call this function and send ether in and stuff like that. And in order for this to accept ether, we have to add another modifier here, which is payable. All right. And if we don't do that, this won't allow us to send ether in with the transaction. So this is how we declare that this function will accept ether, okay? Now here's a new Solidity update. It requires explicitness whenever you're declaring an address that can accept ether inside of a smart contract. And we do that like this. We say address payable wallet, all right? And then likewise, we say address payable wallet whenever we pass this function into the constructor. All right, so that should be a working implementation of what we want to see. So let's deploy the smart contract and try it out. I will take one of these addresses, and we'll take the second address here in the list, and we'll use that as the wallet. We'll actually check its balance here in a second. So we'll deploy the smart contract. We need to pass in a wallet whenever we deploy. Just paste this in, click deploy. All right, looks like it was successful. Let's try to do the buy token function, okay? It's just gonna buy one token for us. So we'll make sure we've got the first account in the list selected. We'll buy token. All right, looks like it was successful. Let's check the balance of this. Oops, I actually pasted in the wrong address. Pasted in the second address. So let's try the balance again. All right, it's 1. All right, now all that did was actually transfer, all that did was buy a token. It didn't actually transfer ether to the wallet, and that's what we want to show. So in order to send ether in and actually transfer funds to the wallet, we would do that like this. We'd change this to ether. I'm going to send 1 ether in with this transaction whenever we call the buy tokens function. We'll do that from this account, and we'll click buy token. All right, boom. So let's check the balance again. All right, the balance is 2. Now, let's see what happened. We can see that the ether value decreased here from 99.9 to 98.9. It actually took ether out of our wallet because we sent it in with the transaction. And we can see that the second account on the list, which I used as the wallet whenever we deployed, has been credited with that ether. So our smart contract worked. It actually sent, the value that we sent in with this to that account. All right, so the next thing I want to show you is how you can create basically a fallback function in Solidity. I guess is what it's called. At least that's what I've seen it called. I'm not sure what the official name is. But basically, it's going to be like a default function that you can wrap this in so that whenever you just send Ether to the smart contract, it executes a function. And you'll see that a lot in like ICOs where they have an address posted and they say, hey, send Ether to that smart contract, and it'll actually buy the tokens for you. Now, this is just a kind of like pseudocode implementation, again, of like a purchase function. A real ICO functionality would be much more complex than this, but you get the idea. So to do this fallback function, we'll do like this. We'll just say function, all right, and we'll say external payable, and we'll just wrap this with the buy token function. All right. So here's a new modifier I don't think we've used yet, which is external. So that's different from public because public can be called, inside of our smart contract as well as outside, but external can only be called outside. So we don't want to like call this, inside the smart contract somehow. So now if we just compile this again and deploy, I'm going to paste the wallet in here, deploy. We'll see you have a new function just called fallback. And we can basically just do that like this. So we'll just send 1 Ether from account number 1, call the fallback, and it worked. We can see our account balance went down, this went up, and the balance of the first account should be 1. Yep, it's 1. So now I want to show you events inside of Solidity. So what do we use events for? So events are a way for external consumers to kind of listen for things that happen on a smart contract. So basically, external consumers can subscribe to events on a smart contract and wait for something to happen. So what we'll do inside of this buy token function, we'll actually trigger an event that lets anyone connected to the blockchain really to know that a token has been purchased from the smart contract if they were to listen for it. So I'll create an event like this. Load up here. We'll say event purchase. And I'll just say, I'll break this line right here. Oops. I'll say address, buyer. And I'll say uint 256 amount. Okay. So that's how we declare an event, just like that. And inside of this function, whenever the token is purchased, we'll trigger it. And we trigger the event like this. We say emit purchase, and we pass in the buyer, and we pass in the amount. So the buyer in this case is msg.sender, the account that's calling this function. And the value in this case is just 1, semicolon. All right, so there you go. Now, another thing you can do with these events, you can create an index like this, indexed, okay? And that will allow you to filter events that are only from certain buyers. So basically, like if you wanted to only listen to events from the smart contract that, a certain person did, a certain account, or maybe even just you could subscribe based on a specific address. So I'll show you how that works. All right. Let's compile this and run it. I'm going to take the wallet, paste it in here, deploy. All right. Now we'll call the buy tokens function. We'll send in 1 Ether. Oops. All right, it worked. Now, how do we know the event worked? So we can look inside of this transaction here, see the log. And we can see right here, here's the log. And inside this log, we have some messages. And this basically is the event. We can see the buyer listed here and the amount. See the buyer was this address. And here's the amount. So what are events for really? There's 2 kind of main use cases for events. Because of the asynchronous nature of the blockchain, if you're building an application that, if you're building an application that talks to the smart contract, you might call a function like by token. Like if you're writing a JavaScript application, you might like call this function, and then your application would just know that you called this function, but you might want to actually wait for this to finish and execute, wait for this event to be emitted. So you can basically wait for that and subscribe to this event, and filter for only ones that are applicable to you. And whenever that happens, you can wait for that to happen, and then reload your application state whenever that event's been triggered. So that's one popular use case. Another use case is you can get the entire event stream from a smart contract like this. So you could basically see all of the purchase events because they're listed in these logs. They're actually listed in the transactions, that are contained in the blocks of the blockchain. And that's a way to see all the purchases that have ever happened inside a smart contract like this. I'll go ahead and use the smart contract that we were working on in the last video as the basis for this one. So in this video, we're going to be talking about how to use multiple smart contracts in the Solidity programming language. Two different Ethereum smart contracts, one that will talk to the other. And I'll also show you how to write, parent-child relationships with smart contracts. So we'll talk about inheritance, a contract that inherits from another one. So I'm going to go ahead and clear out some of this code from the last video to kind of get it where we want it to be. The first thing I'll do is, let's see here. Basically what we'll do is we'll go ahead with this scenario where we're still going to buy a token, but instead of, keeping track of the balance inside this smart contract, we'll actually move it to a token contract to, kind of separate concerns a little bit. So actually, tell you what, let's go ahead and create the token smart contract like this. And again, this is going to be a really just basic, it's kind of almost like pseudocode example. It's not going to be a full ERC20 token, but this will just give you an idea of what's going to happen when two smart contracts call one another at a very simple example. So we'll say contract ERC20 token. And again, if you want to see more, videos about ERC20 tokens, I've got plenty on my channel. So I say string name. So we're going to just have a state variable that keeps track of the name here. Let's actually make this public. And we'll do a mapping. We'll just basically move this balances mapping up here. We'll take it out of this contract. And we're going to extract this balances increment here and put it into its own function. So we'll just call this function mint. Say function mint. We'll make this public. And inside of here, we're just going to do this. We'll take this balances and increment it here, just like that. And also we can rewrite this just to say plus plus, which will increment by 1. Refactor that a little bit, make it a little nicer, a little cleaner. All right. And now we should be able to clean up this a little bit, take these comments out. Let's see here. Let's actually simplify this. We'll take this purchase event out. We don't need all this. That was mostly to show you how events worked in the last video. I just want to simplify the code a little bit so that it's easier to follow along with. All right. So inside of here, we want to mint tokens inside of this contract. So you want to call the ERC20 token from this buy token function. So how do we do that? Well, we created this smart contract in the same file. So because this is in the same file, this contract knows that this contract is here before we compile it and deploy it. So in the source code, this one will know about this one. So we can basically be explicit and tell this contract that we want to mint tokens in this contract. So in order to do that, there's a couple things that we need. We need to know the address of this contract once it's deployed. because this will get deployed and then this will get deployed, and they'll have two separate addresses. And then my contract needs to know about the ERC20 token contract, where it is. And then we'll basically just reference that smart contract with the address. And we'll basically get an instance of it, kind of. And then we'll just call the mint function on it. All right. So there's a two-step process. The first is we need this contract's address, and then we need to instantiate this contract. And then I guess really the third step is we call the mint function. So first, we'll get access to this token address. We'll just say address token. All right, we'll make that public. So we'll just say token is equal to token that we pass in. And we will keep track of it here. Say address token. All right, we can also make this public if we wanted to. So now that we have the address, we need to basically get a instance of it. So we can do that like this. Like I said, this contract source code knows about this ERC20 token here. So basically what I'll do is say, I'll create a new one. So I can say ERC20 token. All right, and we're going to basically instantiate it. And we do that by passing in the token address that we've kept track of here. So it can be explicit, which I think Solidity 0.5 requires us to be explicit. So I'll say address, and I'll say token. All right. So that will reference this ERC20 token that's actually deployed. It knows about this source code, and then it's going to get the deployed token from the blockchain like this. And now we can use this token to call the mint function. So I'll show you a couple ways of doing this. The first one is we can store this to a variable like this. When we create variables in Solidity, or whenever we declare them, we must specify the type first. So the type is going to be ERC20 token contract. And this is a local variable. It's not a state variable. So I'm going to prepend it with an underscore, just kind of a convention. Token. It's not necessary for Solidity, but I do this a lot. You'll see this, all over the place. And now we can mint the token like this. We just say token.mint. All right. So now we can call this buy token function from this smart contract, and it will, use this, call the mint function from this smart contract. So let's check it out. All right, we'll run it. So first, we have to deploy this in two steps, since there's two smart contracts in this file. We'll deploy the ERC20 token contract first. We'll deploy it. Oh, sorry. I'm actually going to use the JavaScript VM. We'll deploy it. All right. And now we can just copy the address of the smart contract that was deployed down here from the transaction receipt. We'll say contract address. And then now we'll go to my contract and deploy it. So it's asking for a wallet and a token address. I'll just paste in the token address, the second argument. In the first argument, I'll just get the wallet. So I'll just copy the, basically the second account from here. So we'll do this account. All right. And deploy. Okay. And now we'll call the buy token function. Boom. We can also see the token address here. And now we'll say, we'll take the balance of our current address that we're connected with to see if it worked. All right, so why is that? Why is it 0? Well, I'll show you why. Well, first, this was successful. The buy tokens function worked. It actually did call the mint function here. But it's confusing because our balance from the account that we did it with is wrong. So I'll show you what's right. All right. So I'm gonna let you guess as to why this might be wrong. Well, instead of leaving a suspense, it's got to do with msg.sender here. Okay. So this can be a real gotcha when you're programming in Solidity and you want to call, a smart contract function from another smart contract. So earlier when we built this, we call this mint function directly. Like if we go here and click mint, right? And now I click balance, it goes up by 1. But if we do it from here, you know, we can click it again, buy token. Let me see it's working, but our balance doesn't increase at all. But if I do mint here, it does increase. That's because msg.sender in this case is the address of the contract that called the function, not who sent it. Okay? Now that's kind of tricky. So we can actually get the address of the person who sent the initial transaction. Instead of MSG sender, we also have access to tx.origin. All right, and that will actually mint functions for whoever initiated this transaction. So if we call mint function directly on the smart contract, it'll increment our balance. And if we call it from the smart contract, it'll also increment the balance of the person who called this buy token function. So that's a real gotcha when you're programming with multiple smart contracts in Solidity that I wanted you to know about. Now I'll show you how this works. So I'll deploy the token first. We'll deploy it. All right, and I'm going to deploy my contract next. Say my contract, and we'll paste in the address. Okay, it'll be the wallet address, and we'll also paste in the smart contract address like this. All right, we'll deploy it. Now, let's try to buy tokens again. We'll do a buy token. All right, it worked. So now let's go look at balances of this account we're connected to, account 33C. This is account 33C. We'll do balance, and it's 1. And if we mint tokens here as well, it also increases. So that's how TX origin works. It's different from msg.sender. It's always the person who originated the transaction, even if a smart contract is calling the function. So I wanted y'all to know that because it definitely can be a gotcha whenever you are programming smart contracts that talk to one another. All right. So I'll show you one other thing before we move on. There's a shorthand here. So whenever we mint this token, we can just do this. We don't have to store this token as a variable. We can just say ERC20 token and then just call the mint function on it directly like this. And that will do the exact same thing. So I don't want to walk you through all that, but I just wanted to show you that that's also a nice, clean, shorthand, valid way of writing this in 1 line instead of 2. Okay, so now I do want to talk about the next topic, which is how to inherit smart contracts. So inheritance, so having a parent and a child relationship. Now we'll create a token that inherits from this basic, ERC20 token to do 2 things. So we'll keep this functionality the same, and what we'll do is basically give this token, the second token down here. We'll give it its own characteristics. So we'll give it its own name. And we'll also override some of the minting functions to, wire up some of our own behavior in our own sort of pseudo token that we're going to create. So I'll say my token. All right, so that's what this will be. And this my token will inherit from this one. And we do basic inheritance just like this. We just say is ERC20 token. So let's customize this token. The first thing we could do is basically override the name. We could say string public name. We could set it to something, default, like my token, right? And that would technically override this, right? That would be basic inheritance, because if we define it a second time, it would override whatever's in this parent class or parent contract. And that shows you how that works, but it doesn't really give us a whole lot of extra functionality. So let's show you how this works in a different way. So I'll set the name inside this parent contract like this. We'll say constructor. Let's say string memory name. Say public. And I'll say name equals name, right? So basically we'll just have a constructor function that's run when this contract is deployed, and we'll take a name and we'll set it to the state variable here. So we can actually override this whenever we deploy our own smart contract like this. We can say, instead of just having the hard value, we can also inherit that we do like this, constructor, string, memory, let's see, name, and I can say ERC20 token name, and that'll pass the name in from this constructor along to this, all right? And let's just say public. Let's say we also wanted our token to have a symbol. Just say string, memory, symbol, okay? And we'll just say symbol equals to symbol. And we'll say string, public, symbol. All right? So that's a way for us to accept our own, argument into our own constructor, but still take constructor parameters from the parent contract. And I'm going to break this up like this to make it a little easier to read. I do this a lot in my, production smart contracts. I break up the lines like this so it's easier to read. All right. So that's how you, override constructors like that. Now inside of here, let's override this mint function as well, okay? Let's basically add some extra behavior. We want to preserve this mint function. We still want to keep track of the balance, but we also want to just do some extra stuff. Let's keep track of the people who actually own the tokens. So first we'll say, we'll keep an array of owners. We'll say address. This will be an array of addresses. Say public owners, all right? And then we'll keep a counter cache of the people who own the tokens. So say uint 256 owner count. All right. And now we will update these values in our own mint function. So we're going to create a mint function that basically preserves the functionality of this, but adds some additional behavior. So we say that is going to be function mint, so we're going to override it, say public, okay? So first thing we want to do is call this mint function so that this behavior is preserved. We just say super mint, all right? And now we say owner count plus plus. We say owners push msg.sender, okay? And that is basically going to call the mint function, the parent contract, to update the balances. Then it'll increment the number of people who own the token right here, and it will add them to the array of owners. Okay? All right. So now let's just compile it and run it. And so when we do this, we don't have to deploy two smart contracts. All we have to do is deploy this one. So we can say ERC20 token. Let's see the string. Actually, let's do this. Let's do my token. So string name will be my token. And symbol will be MTK. Deploy. All right. So let's call the mint function. All right, it worked. So let's see the balances of the current address that we're connected with. We'll say balance is this. Okay, all right. We'll do the name, my token, and the owners of the first person in the list is our address and the symbol. Okay, all right. And we could also make this public if you want to read the owner count. All right, guys, so that's how you inherit smart contracts in Solidity. I'm going to be talking about two different topics in this video that are somewhat related. The first topic is libraries, how to use them in Solidity. And the second topic is math, how to do math in the Solidity programming language. And these are somewhat related because, we use libraries to manage math functions all the time in Solidity. It's a really common use case. So I figured I would just record both of those in the same video. So, what is a library if you're not familiar? Library is basically a way to organize code that can be reused in multiple places inside your project. So that's one of the main reasons we use libraries, essentially to dry code up. So if you're not familiar with dry, D-R-Y, That's an acronym for don't repeat yourself, right? So basically, if we have a function that we want to use in multiple smart contracts, we could define it inside of a library and then use that library to use that function. And that way, if that function ever changes, the change is absorbed by any place that we use it. So how do we declare a library in Solidity? Well, like this. First, we use the library keyword, say library. And I'm going to call this library just math. Okay. So in the earlier videos, I said that smart contracts are the main way that we organize code inside of Solidity. It's called a contract-oriented language, and that's true. But we also have libraries where we can define functions inside of here and store variables and things like that. And that's another way to organize code inside Solidity. But really, at the end of the day, a library belongs, inside of a smart contract so it can get called and used. Libraries don't have the full behavior of a smart contract. They don't really have storage in and of themselves. They don't, you can't inherit from a library, things like that. So it's not really like a smart contract. At the end of the day, it's meant to be used inside of a smart contract. So we can define a function inside a library like this. I'm going to create my own divide function. Say function divide. All right. I'll just leave this here for a second. So why would we want to use a divide function? Well, I'll show you. Let's create an example inside of my contract where we would, basically just do some math. First of all, we'll declare a value. We'll say uint 256. We'll say public value. We'll just store the value here. And now we'll actually store this value, but we'll compute it. So we'll say function, I'll say calculate. And we'll take a value, we'll say uint, we'll say value 1, we'll say uint value 2, we'll say public. And inside of here, we'll basically just set the value to whatever the calculated value is. We'll say value 1 divided by value 2. Now this is a basic way to do division inside of Solidity. We just use this operator here. It's the division operator. So why might we want to use a library for this? Well, you might notice a problem. It's value 2. What if value 2 is 0? Right? There'd be a problem with this. We would get some sort of exception because we can't divide by 0. And that's a really common use case for a library. Basically, we can write some code inside of here that prevents this divide by 0 error, and we can actually stop the function before that happens. So basically, we could do like this. We could define this function and say divide is equal to the input. Let's say uint 256. Let's just say A. Uint 256 B. We'll say internal pure returns uint 256, and we'll do the division inside of here. So say require that b is greater than 0. That's the first thing we'll do. We'll take the denominator and make sure the denominator is greater than 0 so that we don't divide by 0. Then we'll actually create a return value of c, which is c divided by b, or the numerator divided by the denominator, and we'll just return that value. Return c. Sorry, this is supposed to be A. So now we can actually use this divide instead of this divide here as a safer way to do division inside of Solidity. That's a really common use case for a library. So how do we do that? How do we take this function out of this library and use it inside this calculate function like this? Well, we can say math.divide and then just pass in value 1 and value 2. And we store the output to value, just like that. All right, now I'll erase this. All right, now let's try to run this code. So whenever we deploy this, I'm going to select my contract instead of math. And whenever this is compiled and deployed, it knows that my contract depends upon math, so it's already going to get compiled and deployed automatically. We don't have to deploy this first and then this. And the whole compilation process of this file, the math library, at least the part that gets used, is going to get compiled because it's dependent upon right here. So let's try this. First, we can see the value is 0, and we'll say value 1 is, say 100, and value 2 is 10. All right. Okay, that was successful. We see the value is 10. Now what happens if we try to divide by 0, calculate, and we get an error, just as we expect. We can also do some other values just to make sure it works. Say 144 divided by 12 should also be 12. Yep. All right. So that's how you, that's a basic example of how you import a math function from a library. Now, there are a few other ways we can do this. Instead of having this library just at the top of our file here, we can actually move it to another file and import it inside of this file. So we can clean this up, and we're only looking at one, sort of unit at a time. We don't like to look at the smart contract. We don't have to look at this library. So I'll show you how to do that. We'll go over here to our browser, and we'll create a new file. We'll call this math.sol. All right. Now we'll just copy the math library from here. We'll actually just copy it with the Solidity programming language declaration, and we'll paste it in here. Save. Now we can require the file just like this. We say import. We use double quotes, math. All right, and notice I use the dot to indicate the current directory / then the file name, which is math.sol, followed by semicolon. All right, that'll do the same thing. So we can go back to here and deploy this. Go to my contract and deploy. And we'll see, say 188 and 9. All right, there we go. That's doing integer division. That's why it's has no remainder. Okay, so that's how you import a library from another file in Solidity. Now I'll show you one more thing. I want to introduce you to a really common library, which is called Safe Math, which is put out by OpenZeppelin. You can go to that repository here if you want to read more about it. But basically, it implements a lot of helpful functions that I use a lot when developing smart contracts and doing math. They've, they've solved a lot of problems like guarding from overflow and things like that. And so I use this library a lot. So it's a really common use case for me. And I'm going to show you how to use that library inside of here because it works a little bit differently than how we implemented our math library. So I'm going to delete this file and create a new one, say Safe Math. And I'm just going to copy the code here from GitHub, click Edit, and go to, not Edit, I want to do Raw. I'm just going to copy all that, go back to Remix and paste this in here. All right, let's actually change the Solidity programming language version. Let's go 0.5.1. I think it should probably be up to date. Oops. Yep, looks good. All right, so let's save that. Go back to my contract. Instead of importing math, we'll do Safe Math. All right. And instead of, calling a library like this, we're going to do a different way. All right. And this is pretty cool. So we can take all these functions in here like multiply and divide and subtract and add. We can actually call them on unsigned integers directly. All right. And we can do that like this. We can say using Safe Math for uint 256. All right. Now that's pretty cool. I'll show you what that does. Instead of doing this, we can basically say value 1, div, value 2. There you go. That's pretty slick. So let's try that. Go to my contract, we'll deploy. Click this. So value 1 will be 144. Value 2 is 12. All right, the value is 12. There we go. Say 133. 33 divided by 11. Yep. 100 divided by 10. There we go. Awesome. All right, so that's all I got for this video today, guys. Again, you can find all the code examples of this on my website over at dappuniversity.com/article/Solidity tutorial. I'll put a link to that down in the description below. And again, if you're serious about becoming a blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.